Welcome to section 10.3, Probability and Odds. In this lesson, you will learn what probability is and how to calculate the probability of an event occurring. You'll also learn what odds are, how they're calculated, and how they're related to probability. Let's quickly define probability. Probability is just the number of favorable ways that an event can occur, divided by the number of possible ways that an event can occur. In other words, if A is some set of conditions that you want fulfilled, then the probability of an event A occurring is the number of events with conditions that satisfy A divided by all possible events. We'll see what this means here in just a second. Let's look at example 1, dice. In example 1, I'm looking at a 6-sided dice. This is the standard dice used in most board games. A 6-sided dice has 6 faces. Each face is exactly the same size and shape, and each face has a different number of dots on it, numbering 1 through 6. This makes it equally likely that you will roll each number when you roll the dice, because they have the same surface area on which to land. So if we look at part A and ask ourselves, if we roll a dice, what is the probability that we roll a 6? Basically what we're going to do here is we're going to collect all the events that are favorable and divide that by all the total possible events, as our definition of probability suggests. Well, what's the favorable event? That's us rolling a 6. And what are all the events? Well, that's us rolling a 1, or possibly a 2, or possibly a 3, or a 4, or a 5, or a 6. So, and then we count up those events. In the numerator, there's only one event. That's us rolling a 6. In the denominator, there's 1, 2, 3, 4, 5, 6 events. So the probability of rolling a 6, which I'll denote P, and then I'll put in parentheses, 6, that's equal to 1 over 6, which we could convert to a decimal if we wanted to. Okay, so let's look at the second example here, B. If you roll a dice, what's the probability of rolling higher than a 3? Okay, well, let's look at our favorable results. What numbers are higher than 3? Not 3. 3 is equal to 3, not higher. So our numbers that are higher than 3 are 4, 5, or 6. And again, our denominator is going to be 1, 2, 3, 4, 5, and 6. So there's 3 events in the numerator. So I'm going to call this probability of bigger than 3. I'm going to say that's equal to 3 over 6. There are 3 events where you can roll bigger than a 3 out of 6 possible events. Notice that we can simplify that to 1/2, or 0.5. You may have heard somebody say there's a 50-50 chance before, right? When they're talking about things happening. There's a 50-50 chance it'll rain today or something like that. Well, that's the same thing as saying there's a 1/2 probability or 0.5 probability. Notice that 0.5, if you convert it to a percentage, is 50%, right? So when they say 50-50, what they mean is there's a 50% of rolling higher than a 3 and a 50% chance of rolling a 3 or lower. That would be a 50-50 chance. Now, I'd like to just say that probability is not usually defined as a percentage. It's defined as either a fraction or a decimal. But I'll forgive you if you use percentages when you're talking about probability. That's okay. So what values can a probability actually have? So let's think about this a little bit. What if my problem was you roll a dice and I want to know what the probability is that you roll a 7. What's the probability of rolling a 7? Well, you can't roll a 7 because there's not a side of the dice that has 7 dots on it. So the probability of 7 is 0. there's the possibility that the conditions that you have on your event aren't possible. And that's going to give you a probability of 0 of that event occurring. So what's the probability of rolling a 1 or a 2 or a 3 or a 4 or a 5 or a 6? Okay, well, if I roll a 6-sided dice, one of those numbers is going to come up. Therefore, the favorable events are exactly the same number as all possible events, right? There's 6 ways that you can get that, and there's 6 possibilities. So my probability is 6 over 6, which is 1. So, in general, a probability of an event is equal to or greater than 0, regardless of what that event is. And it's also equal to or less than 1, because the biggest probability is that something will always happen. In other words, the number of favorable events is the same as the number of actual possible events. Let's look at example 2, permutations, combinations, and probability. So, you might notice that when you go to your calculator screen, and we do various things with permutations and combinations and factorials, that they're all listed under PRB, and PRB stands for probability. So why is it that these functions are listed under the probability section? Let's think about what we're doing here. When we calculate probability, what we want to do is we want to count the number of ways that an event can occur, and then also count the number of ways that a favorable event occurs so that we can divide those two things and determine the probability. And because of that, counting is integral to doing probability. Let's look at an example. Let's say you're playing Scrabble, and that there are 6 letters left in the bag: B, A, Q, T, C, and E. And let's say that you're drawing 3 letters, and you draw the 3 letters one at a time, and then you put them on your letter board. So I'd like to know what the probability is that when you pull them out and put them on the board, you spell ace in that order. In other words, you pull the A first, and then you pull the C, and then you pull the E. So because order matters, we're going to be talking about permutations. So looking at the bag, how can you actually pull out the letters so that you spell A, C, and E? How many ways can you do it? Well, the first letter absolutely has to come out as A. The second letter absolutely has to come out as C, and the third letter absolutely has to come out as E. And so there's really only one way to do that. First draw A, then draw C, then draw E. So 1 is going to be what's in our numerator. But now we need to know what's in our denominator. Well, what are we talking about here? We're talking about how many different orders we can pull those letters out in. That's permutations, because order matters. And therefore, we're going to need to do 6 permute 3 in the denominator. So let's go to our calculator and go to 6 permute 3. That gives us 120. We have 1 and 120. That's the probability of spelling ace. What if we were drawing 3 from the same 6 letters, but all we really needed was we wanted to draw a Q and an E so that we could then spell the word quiet on our next turn? What's the probability of drawing the Q and the E? Okay, here we're not worried about some freak event where we actually spell a word when we're drawing our letters. We're more interested in just being able to spell a word, and for that we need 2 letters. In this case, it doesn't matter whether we draw the Q first or the E first, right? We just want those letters in our hand. So in this case, we're going to be talking about combinations. What we need is the number of favorable events, that's drawing a Q and an E, and then we also need to have the number of total events. Well, we can do the number of total events just like we did above, except instead of permuting them, we're more interested in combining them. So we're going to say 6 combined with 3, or 6 choose 3 as our denominator. Let's think about what we need. We need the Q, and we need the E. So out of the 3 things we're drawing, 2 of them we have to have. what are the other possibilities? Well, we have one more slot to fill, and we have 4 choices to make. That's really 4, choose 1. What does this give us? Well, 4 choose 1 is 4. And 6 choose 3, if you put it in your calculator, is 20. So that's approximately a 1 in 5 chance of getting the Q and the E. Let's quickly talk about odds. If A is a set of conditions, the odds that A occurs is the number of events in which A occurs divided by the number of events in which A does not occur. And this is sometimes written as A colon not A. Let's look at an example. In example 3, we have a bag with 12 red Skittles and 18 green Skittles. What are the odds of grabbing a green Skittle out of the bag? Well, we want to know the odds of grabbing a green Skittle out of the bag. So there's 18 green Skittles, and then there are 12 red Skittles, so our odds are just 18 to 12, or 18 colon 12, or we could also write 18 over 12. And the reason for this is just exactly what we have, our definition. The number of events in which A occurs divided by the number of events in which A does not occur. There are 18 possibilities for grabbing a green Skittle and 12 possibilities for grabbing a red Skittle. And that's really all there is to it. Looking at part B, suppose the bag has 12 red Skittles, 18 green Skittles, and 4 orange Skittles. What are the odds of grabbing a green Skittle? So, same problem, but we've added a few more Skittles. Okay, well, again, there's 18 green Skittles, so I can certainly say 18. Those are my odds of getting the green Skittle. What are my odds of not grabbing a green Skittle? Well, there's 12 red Skittles, there's 4 orange Skittles, so that's really just 12 plus 4 Skittles that aren't green. Or we could write 18 over 16. Now, notice in both of these, we can actually simplify this, right? 18 and 12 are both divisible by 6. So that's going to give me 3 over 2. And 18 and 16 are both divisible by 2. That's going to give me 9 over 8. If you see these on a multiple choice test, you'll want to be able to simplify your answers. What's the probability of these events that we just talked about in problems A and B? So probability and odds are different. In our first one, in A, we're asking, what's the probability? That's going to be 18 again. That's the number of favorable events. But we have to divide that by all possibility events, which means getting a red Skittle or a green Skittle. So that gives us 18 plus 12, or 30. And notice that 18 and 30 are both divisible by 6. That gives us 3 over 5. I'd like you to do part B. Pause, please, and come back, and I'll give you the solution. Welcome back. So you can see that we did the same thing as we did in part A. There are 18 favorable outcomes, and then there are 18, that's the green Skittles, plus 12, that's the red Skittles, plus 4, that's the orange Skittles, total number of possible outcomes for grabbing a Skittle out of the bag. So that gives us 18 out of 34, which reduces to 9/17. So that's the difference between probability and odds. Probability looks at the number of favorable events as compared to the total number of possible events, whereas odds looks at the number of favorable events versus the number of unfavorable events. Notice that this really changes the restrictions that odds have on it in comparison to probability. Probability must be between 0 and 1, whereas odds, they must be greater than 0. You can't have negative odds. But you could have odds that are bigger than 1. For instance, 9/8. 9/8 is bigger than 1. Well, that pretty much covers it. In this lesson, you learned what probability is and how to calculate the probability of an event occurring. You also learned what odds are, how they are calculated, and how they are related to probability. Have a wonderful evening, and I'll see you in class.